Okay. So we're just going to connect up this this probe. As with any probe, you want to have a look up the top and see if there's any indicator as to which one is the transmit and which one is the receive. Normally you're looking at either a T or a red dot or something like that. Okay, and then if you did get an indication of that, you would have a look at the side here and you would see that one side says transmit / receive. So that's for any monocrystal or single crystal. And then you see one side has received. So if you did have one that indicated to you which one was transmitting, you would connect it to this this one here that says T/R. Okay. In this instance, this probe doesn't differentiate between either side, so it doesn't matter too much. Okay. So we've nominated our frequency at 5 megahertz. We've connected to channel A, and we've nominated the diameter as 10 millimeters. So just this, your most standard of standard dual crystal probes. Okay, this one here would be if we wanted to nominate a wedge. Okay, so we could say that we have a wedge. This is, you could say you have an angular wedge, and you could nominate the parameters for that, or you could say it's flat and nominate the parameters for that one. You can then offset the X for that one, and you can say whether the contact surface is planar, concave, convex, or circumferential concave or circumferential convex. Okay, I think in this instance let's just leave it at 10 and planar. Okay, in this next menu here we can nominate the index point. So the index point is where we expect our sound to come out of the probe, and we can nominate our rotation in regards to our scan axis. In this instance it's normal, so we're talking a 0 degree probe, so we're talking 90 degrees to the scan axis. Then we can nominate our range. So because we're going to be playing with a standard test block, I'll just leave it at 100. Okay, so 0 to 100 is what we're going to be working with. Then we can set our encoding. So because it's conventional, not really going to set any encoding, but if we did use encoding, we could say it was time-based. We could use the scan axis only, or we could use the scan and the index axis. So if we were encoding just for a B scan, we would only use the scan axis. If we were encoding for a C scan, we would use the scan and the index axis, or axes. Okay, then we come to this last setup. So there's a couple of things that we can nominate. We can select a layout, so we have the option of using an A scan with the B scan right next to it, an A scan with a 3D representation right below, an A scan with the B scan on the bottom. We can just look at a B scan. We can have, there's all sorts of things that we can do here. C scan based on percentage, C scan based on depth, all that good stuff. So you just choose the one that you think would be best for you. In this instance, I'm just going to stick to an A scan. Okay, then we can set our starting gain. So at this point, I'll just go and grab my standard V1. And just put some couplant on the probe. And just get an idea for what kind of gain I will be wanting. Okay, so I think we're probably somewhere there, 40, pretty high. let's just go for the first echo at around about 100%. In Australia, you'd be going for the second echo at 100%, but we'll just go for the first echo in this instance. So then we have options here. So these options here represent these options up here. So the first one that I've got for measurement 1 is your mono pulse echo gain. Okay, I can then change it to all sorts of things relating to AWS, relating to DACs, relating to full percentage of full screen heights. I can put in my projection distance for an angle probe. I can put in my estimated depth. I can put in my actual time base, or how long the sound has actually taken to get there. So we'll just leave it at this point, but you do have lots of options to set this up just how you want to set it up. So at this point, I'm just going to accept. Okay. All right. So that's what it looks like when we're in action. So a couple of things. Down the side here, we have 6 shortcut buttons. dB relates to your gain. So we can set things like our current gain, we can set our reference gain, we can auto full screen height, so whatever selected by our gate will auto full screen height. We can set our paths, so our range and whatnot. We can also set things like 0, so this is our 0 offset. Okay, we can set our wave mode, so we've got it at longitudinal wave 5890. Okay, travel mode, half path, full time, half time. So you can put that down however you like. PRF control, so not something that we touch unless we know exactly what we're doing. If we leave it at automatic, it'll be tied to the range that we set. Okay, rectification, whether we want it full, whether we want it unipolar in the positive direction or unipolar in the negative direction, or if we don't want any rectification whatsoever. In floor detection, most of the time we're going to be looking at full rectification. Okay, we can set our filters, our sampling, our rejection. I'm sure at this point we all know that rarely, if ever, gets turned on, and nor should we if we're testing to a standard. Smoothing, contouring, averaging, all of these things are software functions, IFT, and then we can change our probe connections as well if we wanted. Okay. This next button next to the dB is it relates to the gates, so we can move them left, right. If we press the OK button, we can widen the gate, shorten the gate. If we press up, we can move the gate up, move the gate down. Okay, so, and if we use the click wheel, we can move it up and down. Okay. This next one will show you your skip. So you can turn those on and off. So if you've got everything set up properly, you'll be able to know when you're at the bottom of the plate, top of the plate, or going back to the bottom of the plate. Okay. So this button here is probably the